Hey there, all my risk engineering friends. We're here. We're Solar Summer School 2024. You clicked on it. Let's go. So I got to visit 4 solar sites in 3 weeks. I was over the East Coast, the West Coast. I went to the Renewable Energy Testing Center in San Jose, California. I got to talk to operators, insurance company engineers, underwriters, contractors, researchers, maintenance techs, chief financial officers, and risk managers. What did they say? Well, let's find out. Well, let's break it down into 3 sections. I learned about wildfires, I learned about PV fires, and I learned about Hail Stow performance. And guess what? They really work well. All right, let's get into it. The fire lessons between wildfire and PV fire. Let's talk about wildfire. If the vegetation is short enough, the fire will not damage the modules. That's just the blanket statement, and I have evidence that backs that up. So when you look at the vegetation, there's going to be a variety, right? Some of it's short, some of it's tall. Is this short enough? From the facilities I've been to, most of the maintenance contractors would say, yes, that's short enough. From the fires that I've looked at, I'd say this amount of vegetation can cause damage to the modules. So, and it all depends on that greenery. If that greenery is a species that has an oil content and stays green in the wintertime, if it catches on fire, that's going to add some heat to this fire. If it's a species that is mostly water-based and will turn brown during the summer, then it's a periodic return of a fuel load. So you have to be careful about green stuff because it can be combustible while it's green or when it dries out. But the height of it is what determines the quantity of the fuel. The quantity of the fuel is what determines the heat release rate. The heat release rate is what determines the temperature of the equipment on the underside of these modules. All right. Gravel roads can be effective fire breaks. And, I saw some facilities that had sustained fires. And this is not a picture of one. This is AI recreation, basically. But it's how it worked. It's what it looked like. And the fire would get to the road and stop. We'll talk later about, wind effects and the height of the fuel on both sides of this gravel road. They have an impact, and how wide the road is. All that has an impact. Whether the road is covered with straw, which if you're mowing all this dry grass, there's dry straw everywhere. So your roads could be covered with straw and not be effective. You could have green grass on both sides of your road and think, why am I worried about a wildfire there? Well, it dries out, right? There's just one season of the year, and the rest of the seasons are yet to come. And we can't plan when our wildfires happen. They probably happen when it's dry and hot. So we need to be prepared for that. And we're still trying to figure out this one. But just be aware that the vegetation is, and your management of it is the most important thing you can do to prevent fires from destroying the facilities. We've heard about sheep, and the problem is sheep have selective appetites, right? Here they are, they're eating some grass. It's green, it's beautiful, right? And they're not having a great time. What I saw in the facilities I went to was the grass looked more like this, and the sheep aren't really excited about eating this kind of grass. And to tell you the truth, sheep don't like standing around in 100-degree weather. They want to be in the shade. So all of the aftermath when a sheep eats the grass, all of those objects were laid right under the torque tubes in every module. So I mean, they weren't even really spending much time between the strings. They were just under all of the modules. So they really weren't that effective. One of the other things that I learned, and those who watch my channel know that I've been talking about the option of graveling an entire site versus mowing it for its entire life. And I did some little research with AI to help me calculate the costs of both with some assumptions. And you can go to my blog, Energy Risk Engineering Insights.com, to find that. But I was curious about in the field, what do they think about it? And the operator said, well, okay, if you cover a facility with gravel and at some point in the future, your ability to spray weed killer on it goes away because herbicide rules change, now the only way to manage this vegetation is with weed whackers and on foot. You're not going to be able to use mowers anymore because you've got all of this gravel in there. And they're concerned about gravel hitting the modules. So we have to take a step back on this solution that just sounds so great from our perspective as engineers. You've got to talk to operators. You've got to find out how's it going to impact their ability to run the facility. So we want to make sure that we understand any kind of future herbicide plans and that we're going to always be able to maintain the gravel. Okay. Another thought that I had looking at this highway next to the, grass and then the plant fence and then our short grass in there that didn't cause any damage to the modules, we still had a fire come from the public road into our plant. And I thought, well, if we had some sandbags on that fence that it could burn through, that would potentially extinguish the fire. Some might think, well, why hang them on the fence? Why not just put them on the ground and build a sandbag wall? Well, because anything like that is just going to be something else for vegetation to grow on. If it's suspended, most vegetation won't try to grow on it. And it has to be UV resistant. I know there's issues that need to be solved, and I don't know if this thing will even work. But give me a comment if you're interested in this idea of suspending sandbags on certain fences of the solar facility, property, so that we can have that bag melt, drop the sand, and extinguish this fire that's trying to come in from the road from a cigarette. The other thing that we can think about is training the fire department. Now, I'm not suggesting that we have the fire department come into our plants without anybody to keep them safe. But I've seen facilities that are doing this. And can it be done safely? I think it can. We train our fire brigades in our power plants how to fight fires in power plants made of metal floors, and we're asking them to spray water on electrical equipment. We know how to train people to be safe around electrical equipment. I would envision the fire department only coming in to manage grass fires, to keep the roads clear so that the fire doesn't jump across these gravel roads. Because if you've got, again, that cut, dried grass on top of the gravel road, what good's the gravel? So they can come in and wet down that dried grass and keep it from jumping those roads. Do they have to spray electrical equipment? No. So, do we want them to? No. Do they need to realize that the value of that equipment is nothing compared to their lives or compared to this facility? Just keep the whole facility safe by keeping the grass fires from spreading. The reality is, in a solar facility out in the rural areas with no operators on site, the neighbors might call the fire department. The fire department will get to the site and they might cut the lock to get in because they don't want the neighborhood impacted. So we need to approach this head on, train the responding fire departments. Our expectations, that's either that they can come in and here's a key, or it's that they absolutely shall not come in and that they will never get a key. You have to give them your expectations, go out and meet with them, and then train them, if they need the training. It can be done. Now, let's talk about PV fires, the equipment itself in our facilities starting fires, and how we manage those risks and what's going on. What I learned this summer. Well, this summer, one of the issues was mismatched connectors. And back in the past, it was possible that you could have two M4 connectors made by different manufacturers. They could go together, it all worked. But what we're seeing now is that arrangement can lead to hotspots and failures in the future, which could be fires. So the issue needs to be addressed. Do we need to go out and replace all of these components with manufacturing matched connectors? No, we don't need to go out and do that. They're not all going to fail at the same time. They're not going to be a catastrophic failure related to multiple of these failing. Now, we could have a catastrophic failure from one of these that started a fire if we don't maintain our vegetation. But if you're maintaining your vegetation, you don't really need to worry about a fire spreading through the facility. What we need to do is worry about how to address thousands of mismatched connectors. And my view is that we need to keep an eye on them. So having some sort of thermography in place that can see underneath the panels, not just above the panels like a drone would see, but get under the panels to look at the connectors, that would be a proactive approach. And that having some spares which had matched connectors ready to go, and then have a plan that, after we discover the first mismatched connector, we're going to start inspecting the connector. First one to lead to an overheating or a fire become loose. We'll start looking at the ones in that area And if we find any more in that area, we'll expand our search. But we really don't need to just go out and start looking for problems if they're not showing us problems. Once they tell us they're there, then we can start looking a little bit in that area. I think that's probably going to be a good approach for mismatched connectors. Leave me a comment. Let me know what you think. See, they look the same and they are designed, manufactured, built the same, but if they're made by different manufacturers, they just may not stay together. Another thing I saw is what I call one-size-fits-all jumpers. And if you look at larger solar facilities that have tracking modules, the tracking systems have to be able to turn these modules, and when they do that, their supports can't be in the way. So everywhere you see a gap between the modules, there's a support. On the left, you see the supports. On the right, you see the gaps. Well, when the kit comes to install all these modules on all these racks, they send them all these jumpers because the bundle of 6 or that group of 6 modules together there, they all need to be connected. And then that group needs to be connected across that gap, that 8-inch looking gap in there. So what I saw out in the field is, the ones that went between the panels were all loose and proper, no stress on their connectors. But at these columns and these supports for the racks, the modules or the jumpers were tight because they had to go across this gap, this 8-inch gap instead of a 3/4 inch gap. They're just down here tight. So what's the problem with them being tight? Well, they're going to pull the connectors out, or they're going to rub on the steel itself and rub through the conductor or the insulation and start a fire. So this is where we have to be careful about one size fits all. Again, it's not going to be the kind of thing that you go out and replace all at once, but this is more likely to lead to an issue than just having a mismatched connector sitting there with only the heat up and cool down of the air temperature around it to really cause it to move. The ones that are rubbing around those track supports, those are the ones I'd be careful about looking at. And again, it's going to be hard to replace them because there's thousands of those. Filters and fans, what solar plants really consume. Okay, air filters and fans. Why do we have air filters and fans at a solar facility? Well, we have electrical equipment. You see those containers there? You've got inverters. You've got basically equipment that is converting electricity from DC, from the modules, to AC so it can be distributed to the grid. Well, in that process, the conversion of energy gives off heat. That heat has to be rejected or removed from the cabinets, and it's done with fans. Problem is that when you pull air in, you also pull dust in. You start to accumulate dust on your electronics, and they'll overheat anyway, even if you're pulling in the air. So you have to put in air filters. The air filters then get clogged, and if you follow the manufacturer's recommendations, and it says like every 6 months, check the filters, but you're having to replace your fans because they are overheating from overworking because the filters are clogged. Start changing your filters more often. I went out to a facility and saw fans just clipped out of their inverter cases, thrown on the ground. They were laying around, and I saw the dirty air filters, and I realized, okay, this is easy. You can't wait for the manufacturer's recommended time period of 6 months. You need to be coming out here as soon as the compartment overheats, but you need to come out here when that fan fails, or if before that, every month or two. And if that is too often, and you'll know that because your filters aren't dirty at that frequency, make it every 3 or 4. Find the frequency you need for the dust conditions you have. The dust conditions might be different in the summer than they are in the winter. Adjust to it. You can, it's your facility. You can operate it in the way that you have to be in harmony with the environment. Thermal scanning robots, drones, and long-range thermal imaging. This was such an exciting thing. While I was at one of the facilities, I got to see a robot. He was recharging, so we're going to have to remember that robots aren't always working, that they have to sleep too. We all need to take naps. So while I was learning about the robot, it had an infrared camera, long-range thermal, and it had a typical or RGB camera. So it was programmed to roll up and down in between the strings, looking at underneath the modules for hotspots, just what we're talking about. It's not as advanced as I would like to see it, but I do believe it's getting there, and it will come. What it does now is it looks for hot spots, it sees them, it records that, and then when the technician downloads the report, they flag any issues that the owners or operators need to be aware of. My vision is that there's more of a connection that as soon as they see the hotspot, the owners get an alert. They don't have to wait for a report. And, Rev 2.0 is we put a water mist tank on it, and when it sees the hotspot, it goes over, evaluates it, and determines whether it can extinguish that hotspot or cool that hotspot. Future generations have it integrated to where it can shut down the string and then de-energize and then cool the hotspot. I know it's all future stuff, but things are happening so fast that you just never know. Drones, again, for after losses, it tells you what's damaged and broken. Not necessarily great for seeing the issues with connectors and jumpers under the modules. Long-range thermal imaging. After I saw the robot, I thought, boy, wouldn't it be great to have a couple of these just at the corners of the plant, or right along the road, right along the fence that's along the road that people are throwing the cigarette butts out. Some sort of long-range thermal scanning where we can be, aware of a fire before it takes out 100 acres, and that we still didn't become aware of it. That's an idea. Again, I'm going to do a little bit of development. Anybody out there that sells these things or wants to tell me about their solutions using thermal imaging, I'm thinking that you only need a few, and you only need to focus on the areas where you want to see fires. It's not necessarily going to be a little handheld deal like this, but it's the idea is that you'll be able to just watch the whole facility and keep an eye on it when fire starts. Now, let's move from fire to ice. Here we are. It's a big summer of fire and ice, and this is hail, obviously. So I was fortunate enough to become aware of an unpublished report, kind of a recent development, and one day some of this info might get published. But bottom line is that out of more than 60 solar facilities in the United States, ranging from 30 to 300 megawatts, okay, and these things all have Hail Stow systems. And I'm going to tell you how they performed, but first I want to set it up a little bit. Remember that hail-resistant modules, and we'll talk about the resiliency, but they're tested against hailstones about that big, so about 3/4 of an inch. This is the kind of hail that we see in reality in places like Oklahoma and Texas. So the performance of the hail systems, the Stow systems that I'm talking about, has to be kept in light with what kind of hail was hitting them. Now realize that we call it tennis ball size hail. This is not what the modules were tested to. So we would not expect, even with a Hail Stow system, for the modules to survive this kind of hail, right? They weren't designed for it. But guess what? With a Stow event every day from June to September among these 60 plants, we're seeing no damage, right? We are seeing no damage. It's preventing claims. They're having large hail, way larger than what the modules are designed to withstand. But because the Hail Stow is there, they're not being damaged. I would know. I'd be filing claims on all these things. And let me just say, Hail Stow is working. The height or the angle that you stow is important. 75 is better than 60 is better than 45. And the reason is that, when the module is facing the sky, that it's only the projected area that's exposed to the heavy hail. So in other words, that if your module is laying down flat in wind stow, it's completely exposed to all the hail. When you start to stow it and it goes up, the only portion that is exposed is the portion that's facing the vertical. I'll show you a picture of wind-driven rain and some wind-driven hail, but what you have to realize is that that's the smaller particles. That's the one everything's tested to, the ones that aren't going to cause any damage. The ones that are going to cause damage are falling straight down, and we cannot have our modules just waiting to catch those. Okay, the higher the angle, the better. Hail stow is more important than wind stow. Again, you don't want to lay down flat if there's a chance of hail. The damage that's caused by wind when you're in hail stow is not near as bad as the damage that's caused by hail when you're in wind stow. So hail stow is more important. You can see a little bit of wind-driven rain and potentially some smaller hail in this photo here. Okay. Now, another thing you want to do is you want to go into stow quickly. You want to go in when your storms are 25 miles away. You don't want to wait for the storm to get to the site. Okay. If you do, then you're going to be too late. You're going to, you might have some of the equipment stowed and other equipment not stowed, and the act of going to stow might put you in a very vulnerable position when that storm is hitting you. So it's much better to just get into stow, stay there, let the storm pass. 30 minutes, you're back into operation. You haven't lost a lot of production. It beats the crap out of a hail claim. It really does. 25 miles. Get it shut down. Okay, stow every night. Why do we have modules pointing at the sky at night? They're not making power. Get them stowed. I realize the act of stowing can be different for different plants. Some plants hit a button, everything goes into stow. Some plants have to go into the program and change the line of code for the angle of inclination and manually reset the string's angle. And that's how they have to do every string to get the entire site into stow. And if they have to do that every night, it's going to just be frustrating. It's going to take a lot of hours to do that. So it just depends on the system that you have. But just because it's hard doesn't mean that you shouldn't be doing it. If you don't, you're just asking for 12 more hours of hail exposure. And yes, hailstorms happen at night. We had a massive hailstorm in Texas a few months ago. Happened about 2 in the morning. It was dropping hailstones the size of small bowling balls, CDs, grapefruits. They were massive. Stow during construction, right? Don't wait for the construction to be finished to set up the stow system. This isn't on a rack, but set up the stow during construction. As you finish a string, get it energized, turn on the stow. Don't wait for the whole plant to be energized and then say, let's go work on the stow system. Annual stow test. Now, if you're doing a stow every night, I'm not sure you add a lot of value here unless there's different equipment involved in the emergency process of stowing versus your nightly stow. So if there is something that's different, you need to test it annually. There's proposals to do that monthly. Stay tuned. Now, let's rethink hail resistance and resilience. How long can a module or what kind of a hailstone can a module withstand? Well, it depends. If it's never been hit by hail, that's one thing. But if a module's been hit by hail and it's still in service, there's potential for microcracks, which are going to weaken the structure. And a smaller hailstone in the future can cause damage to that module. So just pointing it out there that multiple hits on modules can cause increasing damage that you have to be aware of as you run these facilities. Because there will be a heavy hailstorm at some point, and we want to be ready for it. We want to be protected against it. What we have to be careful of is relying on standards too much and saying, well, I bought hail-resistant modules. Why didn't they survive the hailstorm? Let me help you understand. The hail-resistant modules can withstand the hail on the left. That's the standard test size. The kind of hail that hits our modules is the hail on the right. That's why they're failing. We need standards that match reality, and I think we're going to get there because we can test now to these kind of energies of these bigger modules or bigger hail stones. So part of my visit was fantastic. I don't know if y'all know, my mom was an elementary school teacher. My dad was a professor of nuclear engineering. And I grew up explaining stuff, being asked to explain stuff, being taught how to explain stuff. So it was like, taking a kid to a candy store for me to go to a world-class testing center like RETC. I can't tell you what I saw there or what we talked about, but where I can tell you that, how they developed. They're there to support the industry. They're there to find the things that are keeping us from being reliable. They're there to find the things that are causing insurance claims. And they're there to basically give us an assurance that, when we buy a product, it's going to do what we think it's going to do. So they develop standards that the manufacturers have to meet, that their products then have to come back and be tested against. So that standard then has to be demonstrated before they can sell that product to the public. So it's super to see that there's an organization like this. They're doing great. The facility's awesome. And I just feel honored that I got to go and share some of the information with you folks. So with that, thanks again. If you enjoyed this content, if you want to see more of it, it helps me if you like the video. If you subscribe to the video, then other people will see it and it'll get spread to more folks. With that, thanks again, and I'll see you on the next one.